In this video, we're going to go through a gas stoichiometry question. Now, gas stoichiometry is following the exact same pattern as we did with gravimetric stoichiometry. So I want to point that out before we get going. So here's a grav stoich question. They gave us the mass of a chemical. So that mass is here. And they're asking us what mass of oxygen do we need? So we're always going to be given enough information to get the number of moles of one of the chemicals. So for this question that we did previously, we've got the mass for this chemical, so I can get the number of moles. Then I need to convert to the number of moles of chemical that I want, and then I can find the mass. So it's always going to be number of moles from what I was given, number of moles of what I want to find, and then the mass of what I'm trying to calculate. This is the pattern for every stoich question. Sometimes you're given the number of moles of something, and then you don't need to do that extra starting step. Sometimes you are going to find a different kind of property. So with grav stoich, it was always mass because it's gravimetric. But when it comes to gas stoich, we're going to have different ways to deal with the number of moles, because I can have the number of moles equals the volume divided by the molar volume at STP, or PV equals nRT. And I still have the number of moles equals the mass times the molar mass. And because I've got all of those different ways of dealing with mole, I'm going to use different equations at different times. So in this question, I've got here, it says small amounts of hydrogen are conveniently prepared by reacting zinc with hydrochloric acid. What mass of zinc is required to prepare 2.5 liters of hydrogen gas at 765 millimeters of mercury and 22 degrees Celsius? So I've organized it. I've got my reaction. That's the same as every stoich question. I've been given enough information here to find the number of moles of hydrogen. But first I need to do some conversions. So I'm going to get rid of millimeters of mercury. I need kPa so that I can use my PV equals nRT. So 101.3 kPa is 760 millimeters of mercury. So 765 times 101.3 divided by 760 gives me 101.9, so 102 kPa. But I'm going to use that whole correct number in my calculation. So I'm going to start off, my final answer is going to be the mass of zinc, because that's what it wants. But my first step is going to be finding the number of moles of hydrogen gas. And that's going to be using PV equals nRT. So the number of moles is PV over RT. So I'm going to do that first, because that's how I get the number of moles of given. So when you're doing this, if you've got the correct formula, I'm okay if you just do it all in one row. It's possible to break it down into 3 totally separate steps, but I've been doing it this way the whole time, so I'm going to stick with it. So P is going to be 102 kPa, but I'm going to use the proper pressure that all the digits on my calculator so that I don't lose and double round and make problems. My volume is 2.50 liters. We know that's not a huge amount of gas. And then I've got R, which is 8.31 kPa times liters, mole times Kelvin. Please include all of the units for that, because that's why we are able to cancel and get rid of things as we go. And then I didn't convert my temperature yet, but this is going to be 295 Kelvin. So 295 Kelvin. When I do that, I'm going to be canceling out my kelvins, my kPas, my liters, and it's going to leave me with mole. So I'm getting my mole of hydrogen, which is what I wanted. But I need to then convert from hydrogen and find zincs. I get 1 zinc for 1 hydrogen because I've got the balanced reaction. Those are the coefficients. And then I'm going to find a mass. And in this case, I'm using molar mass. The molar mass of zinc is 65.41 gram per 1 mole. So here I converted the hydrogen to the number of moles of zinc, and then that allows me to find the mass of zinc, which is what they asked me for. So I'm going to take my pressure times 2.5 divided by the denominator And then I'm going to multiply by 1, divide by 1, and then I'm going to take it and multiply it. I get 6.80 gram. I have the same number of significant digits I had here and here. The temperature, I always have a little bit of a tough time calling that only 2 sig digs at 22 degrees Celsius because it's 295 Kelvin. So I'm good with you calling it 3 sig digs, although I would probably be forgiving if you put down 6.8 grams because it kind of makes sense too. So gas stoich is going to be the same idea, but I'm going to need to use one of these formulas, at least maybe 2 of them, if I'm going from gas properties and finding another gas property. Hopefully that helps you understand gas stoich.